Okay, so we're going to talk about the exponent rules, and then we're going to talk about how you can understand what to do without remembering the exponent rules. So, first one is multiplying like bases. The rule says that x, and I'm using shift 6 to get to the exponent, to the a times x to the b equals x to the a plus b, or add the exponents. So here I can look at this example and go 2 squared times 2 cubed is going to equal 2 to the 5th, because 2 plus 3 is 5. But let me show you why that works. So I'm going to have 2 times 2, there's my 2 squared, times, that's this times right here, and then I have a 2 to the cube, so that's going to be 2, 2, 2. So 2 squared, there's those 2, times 2 cubed, there's that. How many 2's am I multiplying together? 1, 2, 3, 4, 5. That gives me 2, and I'm using shift 6 again. Oh, except I wasn't in the equation editor, so it's going to look like that, but that means the same thing. 2 to the 6th power. And I can go even further to evaluate that expression, which means give the numerical value, don't give it as an exponent, by going to the calculator and saying, okay, 2a to the b power, and it was to the 5th power, and that gives me 32. So that equals 32. And that is how that rule comes about. You add, I said 6 and it's 5. You add the exponents and you get the answer. But I hesitate to tell you to use the rule because you guys forget when you're supposed to add and when you're supposed to multiply and when you're supposed to subtract and when you're supposed to, distribute and do other things. So I want you to remember how to write it out. You'll get the right answer every time that way. Okay, so we're going to look at the same situation for x to the a over x to the b. We're dividing here. Remember that fraction bar's name is divided by. So again, with a text box, and I'm going to get the equation editor out, I'm going to do x to the a, x, shift 6, a, and I'm going to subtract b. That is the shortcut rule for dividing powers with the same base. X is the base here. A and B are the exponents. You do the top exponent minus the bottom exponent. This is why. This is what it looks like when I write it out. I've got 7 to the 6th power over 7 to the 4th power, or divided by. So I'm going to need a fraction. There's my fraction. All right, on the top of this, I have 6 7's multiplied together. So I wish I could move this thing over, but I can't. So I'm going to do 7 times 7 times 7. That's 3, 4, 5, 6. There we go. 1, 2, 3, 4, 5, 6 7's multiplied together. And on the bottom, I need 4 of them. So here I go. 1 times 1, 2, 3, 4. Okay. 7 times 7 times 7 times 7. There's 4 of them. And then what I can do is simplify by dividing out these 7 divided by 7. 7 divided by 7 is 1. That makes our life easy here. I'm going to 1 out that one, and that one, and that one, and that one. And now on the bottom of my fraction, I have 1 times 1 times 1 times 1. That's just 1. So I don't even need a bottom to my fraction anymore. On the top, I have left, and I'm going to make this a little bit skinnier. I have this 7 left times this 7. So that would be, and I'm going to do a new text box here, that would be 7 squared. 7 squared over 1, or just 7 squared. I'm going to put my answer down here, which, if I multiply it out, what is 7 to the 2nd power? That would be 49. 7 times 7 is 49. So there we go. 7 squared or 49. 7 squared is what you would give if they ask for the exponential form. 49 is what you get if they ask you to evaluate. This next one, ax to the a, all raised to the b power. So we're raising this whole thing. The parentheses tell us to do something different. That rule would be x, oops, not a, x to the a, I'm going to put the times, oh, come on. They just, I don't know what just happened there. Okay. X to the a, let me see if I can get back over to where I was, and I need times b. There we go. You multiply the exponents in this case. Let me show you what that looks like when I write it out, which I always encourage you to do. You're going to have 2 squared to the 3rd power. So I'm going to have, nope, I'm going to have, really, why is this so difficult? 2 squared, I'm using the shift 6 again, and arrowing out of that, times 2 squared, arrow out, times 2 squared. So there's my 2 squared cubed. I'm going to arrow out of this and get out of the equation editor and enter. I'm going to make this a bigger box. So on the second row here, I'm going to write out each of these. Let's see if I can move that over a little bit. I don't know if I can. No, it doesn't look like I can. Hey, there I can. Okay, so each of these is 2 2's multiplied together. So here comes the 2 2's that I'm multiplying together for each of those. 2 times 2, there's the first one, times 2 times 2, there's the second one, times 2 times 2, there's the third one. So how many 2's do I have multiplied together there? I'm going to put that up there. 1, 2, 3, 4, 5, 6. 6 2's multiplied together gives me 2 to the 6th power, which equals, and I'm going to flip over to my decimals calculator, 2a to the b to the 6th, enter 64. So when I evaluate, I get 64. Again, exponential form, simplify or evaluate. Okay, integer exponents. I'm going to move this over just a wee. Integer exponents. The rule here, if you remember that a negative exponent in the numerator, which this is because, watch me here, if I, oops, I'm going to do black actually. If I make this a fraction, it would be over 1, right? It's in the numerator. If I move it to the denominator, it becomes positive. So, my text box, I am going to have a fraction 1 over x, shift 6 to the n power. 1 over x to the n. You move the variable to the denominator and make the exponent positive. As it moves to the denominator, it loses its negative, as you recall. So 7 to the negative 2 equals a over b. 1 over 7 squared, no, not and, squared, and I need to arrow out of that, which equals, I'm going to write out the 7 squared now the long way, 1 over 7 times 7, which, and again, I'm going to arrow out of there and put an equals, what is 7 times 7? 49, that's right. So 1 over 49. So I have my exponential answer right here in positive exponents. When they ask for exponential form, they want positive exponents only, no negative exponents. So this is what we got when we got rid of that negative, and here's our exponential form. But then when we multiply that out the long way, we get 1 over 49, and that's our simplify or evaluate form. Hopefully that helps you remember or know what to do with exponents. Now let's talk about squares and square roots. A square means you raise a number to the power of 2. And a square root is the inverse of squaring a number, or the opposite. So you undo the squaring. You take the square root. So 9 squared is 9 times 9, which is 81. Negative 11 squared. We're going to do negative 11 times negative 11. A negative times a negative gives us a positive, and 11 times 11 is 121. So positive 121. When we square a fraction, we just square the numerator and square the denominator. So I'm going to get a fraction here. And 2 squared, 2 times 2 is 4. And 3 squared, 3 times 3 is 9. So 4 over 9 is 2/3 squared. Now, to undo that, we take the square root. The square root of 81 equals, I'm going to use a math thing that you haven't seen yet, and I don't know if they have it available here. Oh, darn. They don't, because that would have been awesome if they did. But we have a sign that says plus or minus, meaning it could be positive 9 or negative 9, because 9 times 9 equals 81, but negative 9 times negative 9 also equals 81. So this is how you would put that in Canvas if it was asking you for all the possible answers, 9 comma negative 9. Similarly, the square root of 121 is either 11 or negative 11. And the square root of 4/9 is either, oh, how come that doesn't say 11? Let me see if I can fix that. Nope, go back. Go back. Oh, it numbered it like I was trying to number things. 11, comma, negative 11, and it's best not to put a space in there when you're putting answers in Canvas. 4/9, the square root of 4/9, you take the square root of 4 and the square root of 9. So I'm going to have 2 and 3 here, but I also have positive and negative. So I'm going to put in 2 fractions, oh, but not like 2 fractions. Let's put in this one first. 2/3, and then arrow out of there, put a comma, and a negative 2/3. I know that we haven't talked about that in class, and really if it's just asking you for the square root, giving the positive is what we would assume. But if it is an equation, if it says x squared equals 2/3, what could x be? You would need to give the positive and the negative. Okay, cubing a number is raising the number to the power of 3, and the cube root is the inverse of cubing a number. So 4 to the 3rd power, and I'm going to go up to my decimals calculator here, 4a to the b 3 equals 64. So good deal, 64. Negative 10 to the 3rd power. This is going to be interesting. We're going to do negative 10 a to the b to the 3rd power. Is that what it said? Yeah. Whew. Good thing you were here. And that equals negative 1,000. That's because a negative 10 times a negative 10 times a negative 10 is an odd number of negatives, and that gives us a negative answer. So that would be negative 1,000. And 2/3 cubed, we can do that again. We're going to go a over b. Nope, not there, we're not. Hit enter so you get a new one. Okay, a over b. 2 over 3. Then a to the b. Nope. That doesn't want to work. Oh, you know what we need to do? Put in parentheses. So put a parenthesis there, and a parenthesis, oops, and a parenthesis there. No, I don't know. The struggle is real, my friends. Okay, parenthesis there. Now I want a to the b to the third power. It gives me this fraction, or this decimal value. Looks like 296 repeated, but I want a fraction. When it gave me a fraction, I want a fraction for an answer. That would be 8 over 27. So, fraction 8 over 27. Beautiful. So, if I take the cube root, it's just doing the opposite. The cube root of 64 has to be 4 because 4 cubed is 64. The cube root of 1,000 is going to be a positive 10 because they didn't give us negative 1,000. If it said the cube root of negative 1,000, that would be negative 10. And the cube root of 8/27 is 2/3. So let me put that in. And you can check that math in the Decimals calculator if you want to. But I know, because I just cubed those things, I know that these are the right answers. You have some practice that is a maze, and so hopefully you'll be able to use what we've learned here to do that maze. One more thing I do want to remind you, though. One more thing. So let's type that up here. 0 exponents. When you have an exponent of 0, here's the rule. Equation editor. X to the 0 power, no matter what x is, unless it's 0. But 0 is the only exception. X to the 0 power always equals 1. No matter what x is. It could be 72. It could be negative 3 million. Positive, negative, fraction, decimal, exponent, exponent, irrational number, any number to the 0 power equals 1. The only exception is 0. 0 to the 0 power is 0. Okay, that should help you with your maze. Good luck. If you have questions, I will try to answer them for you. Thanks, guys.